Hi, let's learn about the multiply and divide rational numbers. When multiplying two rational numbers together, firstly check that the rational numbers are in standard form. If you need a refresher, see the videos namely equivalent rational numbers and standard form of rational numbers on simplifying rational numbers. Well, now let's multiply these two rational numbers. 3 over 7 times 8 over 12. 3 over 7 is already in the standard form, but 8 over 12 is not in the standard form. So we can simplify it by cancelling its top numerator and the bottom denominator by the common factor 4. By doing so, we get 2 over 3. Whenever multiplication sign is between two rational numbers, it means you have a license. You can go and cancel from one rational number's numerator to the another rational number's denominator. And don't cancel the numerator by numerator and the denominator by denominator. To avoid making mistakes while doing this step, imagine we are playing a football match where none of us wants to play against our own teammates and score own goals, right? In the same way, don't cancel the numerator by numerator and the denominator by denominator. Here, you can cancel the denominator of the second rational number 3 by the numerator of the first rational number 3 by the common factor 3. So once you have cancelled down both rational numbers, you can then multiply finally. To do this, all you have to do is multiply the numerators together and then multiply the denominators together. In the end, it is better to check twice if we can simplify the answer further. Here we have done it perfectly. Let's have a look at another example of multiplying two rational numbers together. Now let's divide these two rational numbers 5 over 3 divided by negative 2 over 18. When dividing one rational number by another, you should check to see if any of the rational numbers can be simplified. 5 over 3 is already in the standard form, but negative 2 over 18 is not in the standard form. So, we can simplify it by cancelling its top numerator and the bottom denominator by the common factor 2. We get negative 1 over 9. Next, flip the rational number after the division sign upside down. While doing this, we don't need to bring the negative sign from top to bottom. You always keep the negative sign in the top. This is called the reciprocal of the original rational number. Then change the division sign to a multiplication. Then all you have to do is perform the multiplication as we did in the previous examples. Here, you can cancel the denominator of the first rational number 3 by the numerator of the second rational number 9 by the common factor 3. Now finally multiply the numerators together and then multiply the denominators together. You always multiply the sign first. A number without a sign before it is considered as a positive. So 5 over 1 is actually plus 5 over 1. So a positive times a negative equals a negative. Then 5 times 3 equals 15. And 1 times 1 equals 1. Which is just negative 15, since any number divided by 1 is itself. Here is another example of dividing two rational numbers. Now let's talk about these right here. Complex fractions. Well, complex fractions have fractional expressions with separate fraction in the numerator, denominator, or both. Or to put it simply, complex fractions have rational numbers within rational numbers. We just learned how to divide rational numbers that we could easily remember with the phrase keep it, change it, flip it. I mean, leave the first rational number alone. Next, change the division sign to multiplication and then flip the second rational number. Multiplication of rational number is the easiest, right? Because all you need to do is multiply straight across. So now if you have a rational number written in a less friendly way, all you need to do is take the big or main division line and write it as a regular division sign. Then you just put the numerator on the left and the denominator on the right. You're just doing 3/5 divided by 4/7. Now you can solve it just like before. Okay, if you have 2 over 9/8, you just write it as well the same thing. Just listen to how I said it, 2 divided by 9/8. And remember, you can always write an integer as the number over 1. Here 2 as 2 over 1. Then you do the same thing. If you have 5/3 divided by -6, don't even think about trying to cancel anything out like the 3 and the 6. Just write out 5/3 divided by -6, which we know is just -6 over 1. Now keep it, change it, flip it. And remember that while flipping the number, don't flip the negative sign as well. Always keep the negative sign at the top. And then multiply straight across. As you see, nothing even cancel. In this part of the video, we are going to see some common algebraic errors involving dividing out. Well, a good way to avoid errors is to work slowly, write neatly, and talk to yourself. Each time you write a step, ask yourself why the step is algebraically legitimate or algebraically correct. Okay, when some people see this rational, they will just cross out literally anything that looks the same on the top and bottom. And some people watching this might say, you can cancel the 9s and or you can cancel the a's. And yeah, both of these are completely wrong. And here is how you are not going to make that mistake. If you get a problem like this and want to cancel the 9s, first check if that's correct. You just need to do a quick scan. You're gonna look in both the numerator and the denominator. If you find just one addition or subtraction sign that is not inside bracket or parenthesis, should not cancel anything. This is not a perfect method, but it will work for a lot of problems. For our question here, we see there is an addition sign up here. It is not in bracket. Therefore, we cannot cancel anything. This is pretty much as simplified as it gets. In this problem, here you may want to cancel these a's. But before you try, do a quick search. And since you will find there is an addition sign not inside bracket, we cannot cancel anything. If you are given this, you are now allowed to cancel out the a's. Because we check and yes, there are subtraction signs but they are inside bracket. So it's okay. The second you add or subtract any number, say +2 either to the top or the bottom, now you cannot cancel anything as there is an addition sign outside bracket. Yeah, this is not a perfect method because like in our last example, just because of what I said that doesn't mean you can cancel the b's, let's say. That is still wrong, but the reason is really because it's inside bracket itself which has a subtraction sign. Yes, there are other examples I could show where this method won't help, but in most cases this will work. Summary. To put your new knowledge into practice, try the your turn questions below.